Standard 12, exercise 8.9. A 3310 Armstrong photon liberates an electron from a material with energy 3 into 10 raised to minus 19 joules. With another 5000 Armstrong photon ejects an electron with energy 0.972 into 10 raised to minus 19 joules from the same material. Determine the value of Planck's constant and the threshold wavelength of the material. Now here, lambda 1 is given as 3310 Armstrong. Okay. And lambda 2 is given as 5000 Armstrong. And kinetic energy 1 is given as 3 into 10 raised to minus 19 joules. And kinetic energy 2 is given as 0.972 into 10 raised to minus 19 joules. Okay. Now we have to find out the Planck's constant and the threshold wavelength, lambda 0 value. Okay. Now you know the formula, Einstein's photoelectric equation plus kinetic energy. This is the Einstein's photoelectric equation. H nu plus phi 0 is equal to phi 0 plus kinetic energy. Now I can write this as Hc by lambda 1 is equal to phi 0 plus kinetic energy 1. This I will take it as equation number 1. Hc by lambda 2 is equal to phi 0 plus kinetic energy 2. This I am taking it as equation number 2. Okay, subtracting 1 minus 2. So Hc by lambda 1 minus Hc by lambda 2 is equal to kinetic energy 1 minus kinetic energy 2. Phi 0 will get cancelled. So you will be getting Hc into 1 by lambda 1 minus 1 by lambda 2, which is equal to kinetic energy 1 minus kinetic energy 2. Okay. So this can be written as okay. We have to find out H. So H is equal to kinetic energy 1 minus kinetic energy 2 by C into, this can be written here as lambda 1 lambda 2 by lambda 2 minus lambda 1, taking the LCM. Okay. So now we will substitute here. It is 3 minus 0.972 into 10 raised to minus 19 divided by 3 into 10 raised to 8. This is into 3.31 into 10 raised to minus 7 into 5 into 10 raised to minus 7 divided by 5 minus 3.31 into 10 raised to minus 7. Okay. So here this, if you subtract it, you will be getting as 2.028 into, if you multiply these two, you will be getting it as 16.55 into 10 raised to minus 34 divided by 3 into, if you subtract this, you will be getting it as 1.69. Okay. So it is 2.028 into 16.55 divided by 5.07 into 10 raised to minus 34. So you will be getting the H value as 6.62 into 10 raised to minus 34 joules second. So we have found out the H value. Now we have to go for the work function. Phi 0 is equal to Hc by lambda 1 minus kinetic energy 1. So it is 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 divided by lambda value is 3.31 into 10 raised to minus 7 minus kinetic energy is 3 into 10 raised to minus 90. So if you multiply this, 19.86 into 10 raised to minus 19 divided by 3.31 minus 3 into 10 raised to minus 90. So if you divide this, you will be getting 6 into 10 raised to minus 19 minus 3 into 10 raised to minus 19. So you will be getting the value of phi 0 as 3 into 10 raised to minus 19 joules. Now from this we can go for finding the threshold frequency. We have to find out threshold wavelength. So lambda 0 is equal to hc by phi 0. So it is 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 divided by 3 into 10 raised to minus 19. Okay, 3 and 3 will get cancelled. So you'll be getting it as 6.62 into 10 raised to minus 7 meter, or you can write it as 6620 into 10 raised to minus 10 meter, which is 6620 Armstrong. This is your threshold wavelength.